Hello, everyone. Welcome back to Advent of Code 2023. This time I guess I was going to say this time I double checked that I'm not muted. But the problem yesterday was one of my Emacs keyboard bindings is also my mute binding. So I muted myself in the middle, so checking at the beginning wasn't actually what went wrong. Anyway, so we're going to do day 17 today, hopefully. If it's impossibly difficult, maybe I'll just quit forever. That's always been a threat, but 17 is what we're going to try. Day 17, Clumsy Crucible. The lava starts flowing rapidly once the lava production facility is operational. As you leave, the reindeer offers you a parachute, allowing you to quickly reach Gear Island. Yeah, so we're headed back down. As you descend, your bird's eye view of Gear Island reveals why you had trouble finding anyone on your way up. Half of Gear Island is empty, but the half below you is a giant factory city. You land near the gradually filling pool of lava at the base of your new lava fall. Lava ducts will eventually carry the lava throughout the city, but to make use of it immediately, elves are loading it into large crucibles on wheels. The crucibles are top-heavy and pushed by hand. Unfortunately, the crucibles become very difficult to steer at high speeds, and so it can be hard to go in a straight line for very long. To get Desert Island the machine parts it needs as soon as possible, you'll need to find the best way to get the crucible from the lava pool to the machine parts factory. The crucible? Aren't there multiple crucibles? Okay, whatever. To do this, you need to minimize heat loss while choosing a route that doesn't require the crucible to go in a straight line for too long. Fortunately, the elves here have a map, your puzzle input, that uses traffic patterns, ambient temperature, and hundreds of other parameters to calculate exactly how much heat loss can be expected for a crucible entering any particular city block. Oh no, it's A star, but like weird, right? Each city block is marked by a single digit representing the amount of heat loss the crucible enters that block. Starting point, the lava pool is the top left. But we don't incur that heat loss unless you leave that block and then return to it. Which I guess could conceivably be necessary in a, don't go in a straight line for too long kind of situation. Could it? I'm not sure, actually. Because it is difficult to keep the top-heavy crucible going in a straight line for very long, it can move at most 3 blocks in a single direction before it must turn 90 degrees left or right. The crucible also can't reverse direction. After entering a city block, it can only turn left, continue straight, or go right. This path never moves more than 3 consecutive blocks in the same direction and incurs a heat loss of only 102. Yeah. So, this is a pathfinding problem. There are many graph search algorithms, right? This can kind of be represented, this represents a graph in a way, right? Where each node is a location on the grid, and you can go north, south, east, or west from that node. But it doesn't really, because the direction you arrived at a node and how long you've been going that direction influences what node the node has. So you can't just say each cell in the grid is one node in the graph. You have to do more than that. But you can absolutely build not a virtual graph, but you can build a graph out of this grid that incorporates the movement constraints and then do graph search on that, I think. You certainly could. I guess it would be like a Dijkstra's algorithm kind of thing. I've done A star a million times because A star is just like Dijkstra's algorithm with a tiny bit of extra smarts that makes it go noticeably faster. But for this problem, I'm not so sure that I could implement an admissible A star here. I mean, I guess I could, right? It's not hard. So A star is a search algorithm that attempts to be greedy. It explores first in the direction that it thinks is most likely to be profitable. And it does so in a way that is guaranteed to find the cheapest path to the goal before it finds any other paths to the goal, so long as the heuristic that you use for deciding which way is most likely to be the cheapest way to the goal has... I think it only needs one property, which is that it never overestimates. As long as it always underestimates, you will arrive at the destination the cheapest way before you get there any other way. It's just, I've implemented A star too many times in my life. I don't really want to do it again. And Dijkstra, like, is the same thing, but a little bit simpler. Not that much. So you end up doing most of it anyway. I'm actually going to take a pause here and look around if there are, like, Haskell libraries that exist for representing graphs in this way or doing graph search algorithms. So, because I feel like, I don't know, some of the way that I could improve as a Haskell developer is more familiarity with the commonly used libraries and ability to find stuff, right? Writing everything by hand is, you know, a way to learn one thing, but it's not the only thing worth learning. So I don't think it would be very interesting, especially because I don't know. I mean, I'm just going to kind of be browsing web pages for a while, and it's not going to be that exciting. So I'll be back in a bit. I'm back. It didn't take as long as I thought. I just typed A star into Google, and it was like, here you go. Here's a library that does A star for you. And I looked at the type here. I mean, it's a function of what? 1, 2, 3, 4, 5 arguments, which seems like a lot. And they're all like somewhat you might at a glance think, oh gosh, these are, you know, they don't take any concrete types. Everything's so abstract. How could I figure out how to use this? But it's pretty simple, I hope. You need a function that, given one state, tells you what states you can go to next. A function that tells you the transition cost from one state to one of its neighbors. A function that tells you the estimated cost given where you are to the goal, which, remember, in order to be admissible for A star, has to always underestimate, or never overestimate. And a function to tell us when we've gotten to the goal, and then a starting state. And it gives us back, if it can find a path, the cost to traverse that path and the list of states to get there, which is like perfect. This is exactly what we want. It even has this cute little function down here. What is incremental cost again? Does this do anything interesting? Oh, if you need more than just the total cost for the path it found, you can ask it about the paths along the way, I guess. Maybe. I don't know. But pruning, this is the cute little utility function that I saw. It produces a new version of your list of states, or next states function, that throws away states you declare illegal. So you don't have to have your get next state function check whether you're at the edge of the search space. You can just have next generate everywhere you could go adjacent that's at all reasonable, and then prune separately those states which are actually not legal steps to take because they walk outside the grid, or perhaps because they go straight too many times in a row. So it's even a little bit nicer than I had hoped it would be. I don't think we need any monadic whatever. So we just need A star with no M. And I checked that I can indeed include search algorithms in my dependencies and it'll build. I also added linear to my dependencies list, so I can stop just reinventing shitty coordinate classes or types every day. The ones I have are fine, but the one in linear has all the type classes you could ever want already implemented. I feel like it's sort of overkill because this is the linear algebra package, but it was the most commonly, like, it was the least special, what am I thinking? Not special case, special purpose pair of two things that I could find, which seems crazy. Obviously, like you could just write 1, 2. Like that's a really not special case tuple, right? The problem is that because a tuple can have values of different types in it. Actually, maybe it would be better to look at the info of tuple. It can't have all the type class instances that I would want it to have. It's applicative, but the wrong way. It's a functor, but the wrong way. And it's a way that's perfectly useful for tuples, where the two types are different. But if the two types are the same, you can get a different, functor and applicative instance that is often useful, and that's the one that V2 has. Linear defines, V2, which is a vector of 2 elements, and that has, the applicative instance we've been writing every week for our coordinates, for example. I guess I should also add array, because I'm going to want the array of costs. So let me actually stack build that baby and restart GHCI with the new dependency as well. Okay. So, hopefully this shouldn't be too bad, right? Let's get rid of this stuff I never use. We want to import linear.v2.v2 and its constructors. We want import, well, I don't know. I like to put the container types after the other stuff for some reason. Data.array.iArray qualified as A. And I shouldn't need to import indexable either, because of course these vectors are indexed. And they should be indexed in the same order as coordinates were, right? I don't see how they could not, I guess it might be interesting to check. Let me get this. Here's the doc for V2. I'm trying to understand what this means. So, lower and upper, it produces the range, iterating, I don't know how to understand how indexes work. But, it should be okay. I think, probably. I don't know, we'll see. Maybe, in fact, now would be a good time. Oops. It's not. Oh, right. You're supposed to do that. I forgot how to import stuff. Oh, also, I forgot to restart this thing. Yes, I agree that that's redundant and I don't care. So if I say a.list_array from v2 of 0, 0 to v2 of 2, 2, A, B, C, D, E, F, G, H, I intend for this to be in like ABC first. I mean, how am I even going to tell? Oh, I do have to say what type it is. Is that true? Yes. Yeah, and so it's iterating the second coordinate goes up first, kind of, right? In the same way as it did before. So this, I mean, maybe it's just a matter of interpretation. I'm not really sure. But it looks like the second coordinate is our x coordinate because it's going along the top. And that, yeah, so this is the same as all the coordinates we've done before. Index is the same. So, great. As long as we choose to interpret the first coordinate of the vector as y and the second as x, we'll be okay. So let's see. Let's define a type. What do they have? Where am I? What do they call this? Amount of heat loss, thermal permeability, specific heat. What is that? What specific heat means? Maybe. We'll just call it a cost. Cost is an int. We'll store an array of costs in the array. My array is an a.array of v2 int and cost. Now, of course, prepare will fail to work because we haven't implemented it yet. But let's do that. It shouldn't be too hard. Prepare. Same thing we always do. And I guess I need to import textRegEx applicative as well. Well, I mean, so obviously we need this. I think I need psim today. Because I need to identify characters that aren't new lines, basically, to split the lines on. Well, maybe I can do lines separately, right? So what if I said it were map Yeah, maybe that makes more sense. Split the input into lines and then map a function over the line, which is to match it with the line regex, and then insist you can get that it parsed. and then convert that into an array. So for that, I think I basically just need any sim. We'll just, okay, technically it should be a psim that's is digit or whatever, but, or I guess it would be a digit. Then I'd have to import different. Oh, all right, I'll import the different package. Import text regex. Not package, it's a different module, I guess. Digit. There you go. We don't want decimal, because that would be a multi-digit decimal number, and we want each digit to be counted separately. Where line is some digit to int over digit, basically, and we have to get digit to int from here. Haven't implemented make array yet, so of course it is no good. Make array of lines, rows. We already have a function called lines in the global scope, of course, from the prelude. Is a dot list array from. And you know, I keep insisting on doing stuff zero indexed, but the way Haskell's, a number of functions in Haskell work with, like, they're inclusive on both ends. And it would just be kind of nice to start with 1, 1 as the top left instead of 0, 0 for reasons like that. It's a list array v2 1 1. And the upper bound is a v2 where length rows and length of head rows. We'll just assume it's a square or a rectangle. And then indeed I will have to apply that to rows. There you go. Didn't import sum, of course, foolish me. No instance for numchar from digit. In text regex applicative, what is the type of digit? No, not the source, I meant the contents. Oh, it produces the numbers themselves. Oh, okay, so I don't have to call digit to int at all. It parses the digit into an actual digit. I guess that makes sense. I mean, this barely deserves to be its own definition, right? So if we were to say prepare 1, 2, 3 new line. Oh, hang on, I need the new lines, don't I? All right, put this back. Oh, no, I called lines. I'm only looking at one line at a time. Yeah, so that parses and says there's an array supporting x and y between 1 and 3 inclusive. And at row 1, column 1, there's a 1. Row 1, column 2, there's a 2. Row 1, column 3, there's a 3. And then on to row 2. So that looks perfect. Certainly less work than I've done to implement coordinate grids in some previous exercises. What am I supposed to do next? I want to run a star over this, sort of, right? But that means I have to define a node type and a transition functions and costs and so on. And to do that, I'll have to have a graph in scope, or a grid. Let's actually call this a grid, and then we can down here say type input equals grid. That way I don't have to refer to the input of the entire program in my algorithm, right? I'll just refer to a grid, and then down here I'll say, oh, by the way, the input is also a grid. So what does the A star package call all the functions I have to write? Of course it doesn't. They're just arguments to its function. But they do have an example here where they say, oh, let's define these 5 functions, and then an example of calling A star using those. So they suggest neighbors. Fine. Neighbors actually doesn't even need a grid in scope, right? It can just take a v2 and produce 4 other v2s. Although actually, I wonder if there's already such a function in linear somewhere for v2, right? Probably not. I don't know what this shit is. Oh, wait a minute. R1 of t. What the hell? Okay, basis vectors. Yeah. This seems plausible. Maybe? V1 of 2 get x is 2. V1 of 2 set x to 3 is 3. And then R2 has x and y, and it uses these lenses, sure. Oh, look at that. It has perpendicular vectors. You can rotate vectors. This is nice. I don't know what E is. We'll think about that later. But what do I know I can call x and y on a v2. Why was I trying to look this up again? Because I wanted to find the neighbors of some of it, right? A fine? What's a fine? Doesn't look relevant. Metric? No, I don't know enough about linear algebra, but that doesn't look right. Distributive? Surely not. For any functor, you could turn f of v2 into a v2 of f? Like, suppose f were maybe. What would that mean? You could have a maybe of v2s and produce a v2 of maybes. Okay, sure. Doesn't seem like it helps me. No. I feel like R2 is closer. Some way to say go exactly one in a particular direction, right? Well, I mean, we could use the functions in lens to operate on x and y, I guess. Let's just double check. What is this E thing? A basis element? Oh no. Oh, stop with the coalgebras, man. A basis for a vector space. A unit vector? Oh, is that interesting? Ooh. It kind of is, actually. Right? We could say unit of x and unit of y, and negate unit of x and negate unit of y. Or negate head. They didn't want to call it negate because that's in prelude for numbers. Okay, that actually looks sort of promising. What is this in? Linear.vector? Well, actually, before we can define the neighbors function, we kind of need to figure out what type our node in a graph is, because it's more than just the location. Remember, it's the direction you've been going and how long you've been going it. So let's say data node is a node containing a v2 of int. Let's actually say position is a v2 of int, but so is direction. And momentum is a single int, how long you've been going in that direction. Deriving. Now these nodes actually have to be ORed because they're going to be in the map that A star is keeping track of, which is fine. We need show, eq, and ORed, and that probably is all. And then we can say neighbors is a function from node to list of node, I think, right? That's the right type for this. Yes, anything foldable and list is foldable. So neighbors of node P and D and M, I guess, is do D prime from right. We need to know the old direction so we can tell if it's the same as the new direction. But the new direction doesn't depend on the old one at all. from, I mean, it's basically unit of x, unit of y, negated unit of x, negated unit of y, I think. We have to import unit. And are x and y in the unit? Are they in the same... I know they were in, like, they're not part of E, they're part of... I guess they're in V2, basically? Actually? Or no, unit was here. X and Y are there? Is that right? Yeah. I know I'm not done writing my do. Node of P plus D prime. V2s are numberable, so we'll just add them, I believe. And D prime is definitely the direction we're going in. We just have to compute the length. There's got to be some clever way to do it. It's m plus 1 if the directions are the same, and it's 1 otherwise. If. I mean, kind of gross, but d equal d prime, then m plus 1 else 1. Pure of all this, please. Negated came from here, I think? Yeah, it's all parses. And type checks, even. So, that's cool. This is so much less work than doing it by hand. Finding my own stupid coordinate type every day. Refusing to even define my own library for it, but Edmund's... Wait, Edmund? Is that his name? Edward. Edward Kmet? I'm forgetting now. Edward Kmet, yes. Edwards is better. Unsurprisingly. So these are the neighbors of a node. And then we're going to need to trim, like to prune, I guess. But I don't know. Maybe I'll just... Well, no. I was going to say I'll do all this in part 1 because I don't know how part 2 is going to change the requirements. Which is true. But most of this, I assume, will be reusable and should really just be top-level functions. What's the next thing that A star wants? It wants a cost function. From state to state cost. So that's easy. Cost is a function from grid to node to cost. Now, you'll notice I said the cost function I'm supposed to supply takes 2 nodes and returns a cost. This one takes a grid as an initial argument. That doesn't type check. Well, the point is I'm going to partially apply this to the grid that we have. Like, is it really just this? Nope. Hey, wait. Oh, of course. I have to destructure the node, or pattern match the node. Sure. So that's the cost for moving to a new state. We don't care where you're coming from. We just know how much it costs to get there. What's next? We need an estimated cost. That's also easy. We would usually call this the heuristic or estimate or something. What do they call it in the example? They don't name it. They just have it take a distance. Sure. Actually, let's look around in the linear functions for, is there some... How do I compute the distance between 2 points? Wait, don't I just subtract them? I think so, because it should do just subtraction point-wise, right? Let's go look at v2 again. And what is the num instance or num instance or what have you? I don't care about the coalgebra. Here. Yeah, it's just lift A2, so it's pointwise. So it really is just subtract the goal, or subtract the current location from the goal. That will definitely always be an underestimate of how long it's going to take to get there, which is what we need for A star. But it does mean that cost, no, not cost, let's call it heuristic. It's the A star heuristic. You know what? A star heuristic, to make it very clear what we are heuristic sizing of G is. Now I'm taking G as a parameter here. Okay, I guess I should give this I should give this a type. Takes a grid and a node and returns a cost. And so we could do the same thing we did here. I plan to partially apply this to G, but I don't have to say that in the definition. I can just say it takes G and a thing, right? However, in this case, it's actually a little bit better to say this or something of that sort. Because we can say where go is goal minus go of node, go of P, go of N. Is goal minus pos of N. And goal is... I'm trying to get to the bottom right, yeah? I assume? Where am I trying to go? Destination is the bottom right. Yep, okay. So goal is A dot bounds of G. Yes? V2 int. Oh, that's true. I then have to add up the elements of the V2. I mean, I think it's just sum. Oops. Yeah. Because a V2 is foldable as well, and I can just sum it up. So the point of this is that at the time that I receive the G, the grid, I can, before I actually get a specific node coordinate, I can call bounds of the grid once, extract the goal once, and then every time I get past a node, I can just subtract the goal I already was given. If we took both parameters like this, it wouldn't do any work until it had both parameters. So this is a way to take some repeated work and lift it up a level so it doesn't get repeated. And then we need illegal. Takes a grid and a node, I think. Oops, is pruning. Yeah. It wants nodes. Cool. Node bool. Illegal G is go again, where, and I have to get We'll just get the whole bounds. Go of n. It's illegal. I don't know. I kind of do need. Well, it's illegal if let's maybe do it this way. If not, oh, and I do need index. I need to import the dang old index class because I need to get in range. Or maybe that's in Prelude. I don't remember. Not in range bn is true. That's illegal. And go of I don't know. I mean, I should really just say is if the thing is not in bounds or in rands. What am I saying? In range. Or they call it momentum of n is greater than 3. What's my can move most 3 times in a single direction? Yeah. So I think that's it. Okay, I can import that. Oh, I can see it's in array re-exports it, I guess. Okay, fine. Okay, yeah, indeed. I should have said the position of n. Oh, I forgot to put the underscore in front of momentum. So there you go. We got this nice illegal function. And I think the last thing to do is to say whether it's solved, right? Scrolling. We already estimated the cost. Yeah, we just need a function that says whether it's solved. Solved, again, takes a grid and a node and returns a bool. Solved of g is go, where... Now, all of these, like, in principle, if you inlined them all into part 1, they could all share the bounds of g, and you wouldn't have to call bounds 3 times or whatever. It's not that big a deal. Well, actually, I can just say equal goal. I don't need a go function. Where the position is equal to the goal. And we're set, right? I think I'll say that part 1 returns a maybe int. Because our pathfinding could fail. Part 1 is fmap first to get the cost out. A star of... Actually, I should take the G. The functions I'm calling are first neighbors, I think not needing a G, right? Yeah. Then cost A star heuristic. Oh, but I'm supposed to prune that, right? Yes. Neighbors pruning illegal. Cost G, A star heuristic of G, and solved of G. Did I import A star yet? I guess not. That's in algorithm.search. Could match maybe int with node to maybe cost. Compose is applied to too few arguments. Sure. Yes, and of course, it doesn't want the grid as an argument, it wants an initial node. What exactly is our start like? Oh, and my neighbor's function is wrong because you're not allowed to turn around. I forgot about that. I just found all the neighbors of a node because it seemed like a cool thing to do. Okay, well that's one small fix to make first before I get into what the starting node is. Where am I? Neighbors of node. Do I try to guard here? Guard that D prime is not negate of D, negated of D. You're not allowed to make a U-turn. We're gonna have to import guard from control monad. Okay, now back to the problem I was about to solve before I noticed a different problem, which is the start position. I think we're going to construct, because it doesn't tell us, I think, which direction we're going, right? It says you start in the top left, but it doesn't say you're already moving east or something like that. You just, I think from here to here would be your first move in the east direction, and from here to here would be your first move in the south direction. So we'll just say you moved to the south 0 times, or the east 0 times, or something like that. Or frankly, we could even say you stood still 0 times. That would be okay as well. Let's define some helpers here, so that this one line is not quite so long. Start is node of v211, v200, and we're stationary. I feel like that's a fair thing to say. It'll say, oh, all 4 directions are legal from here, but then the 2 that move it outside the grid will get pruned, and it'll be fine. And our momentum is 0. We have moved stationarily 0 times. Illegal of G. Hey, type checks. Any bets? I mean, I didn't write any code myself, so it must be correct. All the interesting code is in pathfinding algorithm, right? $963 seems plausible. let's put it in. I'm a little, like, it took a little bit longer than I thought it would, so I'm a little nervous, but I don't know. We'll see. That's the right answer. Great. Day 17, part 1. Nice and simple. And let's... How long does it take to run this without stack in the way? It doesn't take no time. It takes almost 5.5 seconds. I would have thought it would be a lot faster than that, but I guess our heuristic isn't very good. And the graph is a little bit bigger than it looks because of having to track directions as well. So it's kind of like 3 or 4 times the size it looks like. I haven't even looked actually at how big the graph is, come to think of it. I haven't even glanced at my input. So, I mean, okay, it's 141 by 141. I don't know what 141 squared is, but like 20,000, 30,000, something like that. 25,000 times 3 times 4 for the storing the momentum in the direction we've been moving in. So like times 12. 12 times 25,000. Is that only 300,000? It's not huge, but it's not tiny either. It's not implausible that it would take a while to get to the end. Anyway, we did it. Let's see what's up with part 2. The crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine parts factory. Instead, they're going to upgrade to ultra crucibles. Not only do they have trouble going in a straight line, but they also have trouble turning. Once an ultra crucible starts moving in a direction, it needs to move a minimum of 4 blocks in that direction before it can turn, or even before it can stop at the end. Interesting. So it has to travel straight for at least 4. But at most 10. Okay. So I think, I mean, it's not 100% trivial to change this because, like, we're going to have to change illegal and solved. And I think that's it, right? All the costs and neighbors and heuristic can remain the same. We just need a different illegality cost. And a check that we've solved. That we've moved far enough in a straight line before we can declare the problem solved. But I think that's just adding like 2 parameters to illegal and 1 parameter to solved, and then we're done. And let's just add 1 constraint to each of them, where we declare a data wobbliness is, and this is just going to be a tuple of 2 ints basically. I could use v2, but I don't like it because we're not using it really as a vector here at all. Wobbliness is a wobbliness of min momentum and max momentum, both of type int. And we don't need any of these. We don't need to drive anything for this. illegal now has to take a wobbliness low and high, I guess. So it's illegal if, well, it's now destructure n, I guess, or pattern match it. Node, pause, don't care about the direction, momentum is m. Or m is greater than high, or m, no. It's not illegal to have your wobbliness be less than the minimum, is it? Oh, this is kind of funny. Because now we can't just do this in illegal anymore. We need to know about what the previous state was. We can't just say this state is illegal. So I think it's fine for illegal to take a wobbliness and we pass it high. And it only uses high. The maximum amount you can go straight for. And then we just have to say illegal of wobbliness 0, 3? Yeah. And if we run this, it should be fine, right? Yeah, same answer. Okay. I mean, really, I guess we should define a solve function here. Solve takes a wobbliness and an input and returns a maybe int. And it's basically just like this. Solve of WG. Part 1 is solve of that, right? Check one more time I didn't screw it up. It type checked, like, and it was a really simple edit, so it should be fine. But just in case. Yeah, okay. So now we can basically say part 2 is solved with a new wobbliness, but we're going to have to implement a new version of the neighbors function, I think. Or neighbors is going to have to take a wobbliness as well, right? Cost can say the same. Heuristics is the same. Solved is going to have to get a wobbliness. Yeah, okay. So now it doesn't type check anymore, as intended. It has to go straight for how long? At least 4? Yeah. And at most 10. Okay, so we're done. We did it. Part 2 is finished. Oh, whoops, hang on. Solve. The problem is we have to, the stuff that was finished before isn't finished anymore, so we have to go fix that. Neighbors needs a wobbliness and solved needs a wobbliness. Well, solved should be easy. We don't care about the high here. Is that and now we actually need a go function here, sadly. I mean, we don't have to, but go of node PDM is m greater than or equal to low and p equals goal, I think. Now neighbors needs a new argument, and that's exciting. Wobbliness to node to node. Wobbliness of low? And then we can ignore high, I think. I think we can just say if m is less than low, well, it's certainly not allowed to do anything but go straight. So we'll say it's go of D, the direction it was already going in. Otherwise is go of D prime, basically, from here. Go of D prime where go of D prime equals not used D. What do you mean not used? I'm using it right here. Are you pointing out that I'm not using it in this body? It says D right here. I'm also using it here. Oh, line 47. Sure. All right, that type checks. Anyone want to place any bets? This seems reasonable. Let's give it a try. Stack run, please. Taking more than twice as long as the last one, I think. It's a little nerve-wracking. Okay. It's longer. Seems plausible. We're less flexible. It should be longer. Well, we're also more flexible. If we want to go through straight lines, we can, I guess. But it's a number anyway. Let's see how it goes. Too high. How dare you? Okay. Actually, here's something I realized. I could The call to pure could be inside of go. I could just say this, right? Same thing. And for a change, go is actually like an almost semantically relevant name for a function because it's like, oh, to go in this direction. How nice. So I guess let's first make sure I understand the new constraints. Needs to move at minimum of 4 blocks. Oh, did I forget to amend the goal function? I didn't, right? I remembered to do that. Solved. I mean, that looks right. And this little edit here hasn't messed up the momentum. It will continue to grow because we go in the same direction. It is a little bit of wasted work here. We have this if condition that we're checking even in the case where we know it's definitely going to be true. That's life. Not a big cost. The A-star heuristic is still admissible, right? It definitely can't take you longer to get to the goal than if you could just like turn straight there and walk through a cost of 1 every time. Actually, there aren't any zeros in this list, right? No. Okay, good. That would have been a mean trick. So I don't think cost or A-star heuristic have become a problem. We can still say illegal. The bounds of G, if you're not in that range, it was an illegal step. And if you allowed your momentum to get above high, that was an illegal step. It isn't checking whether you turned sooner than you were allowed to, because we can't really check that. We have to do it in neighbors. If M is less than low, i.e. you have not yet traveled long enough, then you can only continue going straight. That seems right. Wobbliness should be 4 to 10. Really, we could say 1 to 3 here if we wanted, but it's fine. Actually, because our initial state that we decided on. Oh, wait a minute. The initial state that we give is, we gave it a momentum of 0. We said, oh, because in the initial part 1, we said that we'll just start you in the northwest corner and we'll say you're stationary. And that'll be fine because you'll just turn in all 4 directions. But for part 2, stationary, while not a direction that any of our that our neighbor's function can generate, it's still a valid direction, and you can build up momentum in that direction. And if your momentum isn't at least 4, will say you got to keep going in the direction you're in. So we actually made it sit still on the start for 4 rounds, accumulating heat loss before it started moving. So I predict our answer was too high by 20. And I could just like test that out by inputting a new number that's 20 lower. That's actually, let's do that. It'll be fun. So I input 1198. I want to put in 1178 and see if they agree with me on that. That is the right answer. Okay, I'm on the right track with what the problem is. So there's a few ways we could fix it. Which is, like, I think the easiest one is to just say and d is not 0. And since vectors are numbers, 0 should be, I mean, let's check, but 0 of v2 of int, that's a v1 of int. Yeah, it's 0, 0. So if, only if the, equal sign, there we go. If your direction is 0, you're kind of like exempt. You're allowed to go whatever direction you want when you're stationary. So it'll try all 4. But if your momentum is ever below low and you're not stationary, then you have to keep going straight. And I believe that when I run this, it'll give us 1178, the correct answer that I've already input on the site. It's nice to have, like, I don't know, a bunch of libraries around. Obviously, like, every popular programming language has these. But, like, this A* function is perfect, right? I don't know. Very easy to use. Well documented. Does exactly what it's supposed to do. And accessible with just a quick search for A*. Yeah, 1178. Cool. So I think we're just committing all this, right? Is there anything in here that looks stupid or bad? I don't know. No more so than usual, I guess. Day 17, part 2. Nice and simple today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.